One of the key concerns in higher education that emerged during the COVID era was the independent, self-regulated learning we expected from our students. For students on professional programs, the ability to manage yourself, your resources, your schedule is linked to the ability to make professional judgments, a key outcome of engineering programs. Today, on behalf of my colleagues, Professor Booysen and Mr. Coetzer, I'm going to take you through an ongoing program renewal initiative in our electronic design course, where we explicitly addressed the development of what we're calling self-efficacy. We're from a research-intensive institution in South Africa, and we have an active program renewal initiative across the faculty. Now, the module we're focusing on today is a third-year electronic design module for an average of around 128 students. Now, in this module, students have to build their own circuits with a range of components. They're given different weekly assignment briefs with different functional requirements. Now, some of the required knowledge is already known, but things like working with batteries, solar panels, and thermal dissipation, for example, would be new to them at this point in their third year. As a result of COVID-era remote learning, the LT-SPICE simulation environment was implemented, but it was clear that students were struggling to work independently in this environment. Now, in 2021 and 2022, a number of formative steps were added to the course design. By this year, practically, students were required to do the following. They had to do a small literature review on the given weekly task, design the relevant circuit, physically build the circuit and measure the required outputs, and then simulate the circuit complying to all the requirements of that weekly task brief. All of this had to then be compiled into a small report. Now, the initiative we're particularly interested in today is the addition of self and peer assessment techniques to enable the students to develop a better sense of their own progress and performance. Theoretically, we're drawing on Bandura's concept of self-efficacy, which is the ability to exercise control over your functioning and cope with events that can affect your life. It's like the development of self-awareness, realistic self-awareness. Now, self-efficacy is developed through practice, which leads to mastery. Vicarious experience, which is experiencing something through someone else. Social experience, belonging to or being involved in a group with the same objectives. And the fourth factor is emotional state. For example, you're less likely to develop realistic self-awareness when you're highly stressed. Now, developing self-efficacy is linked to coping, resilience, and confidence building. And these are all attributes we desire for our students, our future professional engineers, who are going to have to exercise professional judgment. Having observed in a previous paper concerning gaps between student and staff perceptions of student progress and performance, the e-design module this year focused on improving self-efficacy through multiple reflective, formative, self and peer assessment opportunities. So, 3 of the weekly assignments across the e-design course, which is actually a 12-week program, were selected as the target for specific self-efficacy development tasks. Students were given a broad rubric to guide their actual circuit building tasks and a detailed rubric for conducting self and peer reviews of those tasks. Following the self and peer review process, they also completed simple surveys to reflect on things like having had enough time or improved their understanding after reading each other's reports. Now, one initiative that was added from the COVID era was student-led problem-focused online tutorial discussion sessions. Now, let's look at the results of these initiatives. Now, before each of the 3 self-efficacy focused assignment tasks, students were asked whether they had had enough time whether the literature survey and the writing of the report were easy. What's interesting here is that having been made to think about this already, by the time they get to the second self-efficacy assignment, they report that these elements have become easier. Note that the tasks themselves are increasing in complexity. Another interesting observation in terms of self-assessment is around their sense of time. After the peer review process, they all amend their answers to the time question, indicating that in fact they had more than sufficient time than they had initially thought. Now, for the peer assessment process, we were interested in students' perception of how reviewing someone else's work improved not only their understanding of the concepts and the tasks, but their perception of the level required. Now, over the graphs that you can see here, you'll notice from B to D, which represent the self-efficacy focused tasks 1 to 3, there is an increased level of alignment between the students' estimated marks for their own work and the marks awarded by their peers. By assignment 3, most students have developed not only increased confidence, but also increased accuracy in their ability to assess their own work. Now, we argue that this overall result is a temporal decrease in the error of the estimates produced by the students. And we believe this indicates that there is an increase both in confidence and self-awareness. Now let's take a look at the qualitative results in terms of our theory. Now, first and foremost, the repeated tasks and the 3 specific self-efficacy tasks were designed to improve mastery. This is your classic practice makes perfect ethic. We see from the student feedback and performance improvements we see improvements in their time management, their research skills, and the report writing, as well as their engagement with the LT-SPICE simulation environment. The improvements in aligning their standards are evident through their vicarious experience of other students' work, which is exactly what the peer review process was designed to enable. Now, the collaborative, student-led online question and answer sessions represent the broader social experience of belonging to a larger group, all with the same objective: to bridge the gap between theory and practice, to share in the collective understanding, to help each other develop in this kind of collective, and I would almost say emerging community of practice. Now, the scaffolded course design as a whole was intended to develop confidence over time so that students didn't have to face that typical end of semester huge project workload when they're typically more stressed. Now, as a team, we're acutely aware that this initiative may simply come across as a victory narrative. Some may argue that a class of around 128 is not particularly large, but in truth, the improvements in this course have evolved over a number of years, and they've entailed significant design elements with the accompanying workload and the heightened context awareness of the lecturer in question, my colleague, Professor Thinus Booysen. Now, this well-designed scaffolded course has evolved as a result of his sensitivity to his students not coping with the sudden challenges we all face during emergency remote teaching, but also because of his commitment to effectively integrating technologies, both in terms of teaching, how he uses the learner management system, and in terms of the students' learning, having the physical devices and the digital platform in which to test their own understanding. Now, the ultimate goal we all share is to provide our students with sufficient opportunities, both individually and collectively, to become confident, practicing engineers who are going to tackle the challenges of our time. Thank you very much.